In this video, I'll show you how you can find the 5-number summary using some basic calculations and then also the calculations provided by Excel. The first step is to look at our data, which is the top 30 movies of the 2010s, and we want to find the 5-number summary for budget in millions. One easy way to look at this data and work with it is to copy this column budget in millions and put it into its own spreadsheet. So I'm going to bring it over here and I'm just going to drop it into one of the columns, maybe here in D. Then I'm going to sort the data. We know that the 5-number summary is based upon the rank of the data. So the first thing is I go to data and then sort. This will sort my data from smallest to largest or largest to smallest. Here we want smallest to largest, so I'm going to press OK. Now, right away, I can see my minimum value and my maximum value of $400 million for a budget. The next step is I'm just going to create another column called rank and put these in as 1, 2, 3, and so on. And I can type all those in, or I can type them in 1, 2, 3 and drag them down. This will allow me to recognize that the rank of that particular value, which will be helpful when I'm finding the 5-number summary. So recall the 5-number summary is the minimum, Q1, Q2, which is the median, and Q3, and then finally the maximum value. So the minimum value we already know, that's 1.5, and the maximum value we saw at the bottom of our data, the 30th observation, is 400. To find the median, we need to find the mid-rank value. So here the middle value between for 30 observations is going to be the average between 15 and 16, which are our two middle observations that split the data in half. We can see that the values that correspond to those ranks are 18 and 20. We just simply take the average of these two values, which 18 plus 20 would be 38 divided by 2 is going to just give us 19. So we take the average of those two, and that will be our second quartile or median. Then in order to find the first quartile, we'll just split the data in half. So take the first 15 observations, so the first half of the data, and find the median of that first half. So we know now we have 15 observations. Since this is an odd data set, or an odd number of observations, we simply just take the midpoint, which is going to be one observation. Specifically, it'll be 8. So that will be 4.5. And for Q3, we do the same thing, but then with the second half of the data. So 16 through 30, those observations, and we take the midpoint of that. And so if you were to count up 1, 2, 3, 4, 5, 6, 7, 8, that's going to be my middle point. And so the third quartile will be 90. Now, in order for us to get the interquartile range, this is simply just the difference between Q3 and Q1. So the interquartile range in this example is 85.5. Now, another way that we can find these values is through using the quartile function. And sometimes this might give us slightly different values than what we grab by hand. So the minimum and maximum values will be the same. So putting in quartile, then using the command quartile, we can select the array of data. So put in our number of observations, and then come back up to the top. And here we want to put in 0 for the minimum value. We can see that the minimum is exactly the same as what we calculated by hand. Now for the next set of data, we want to put in quartile. Again, select our array of data. And here then we will put in 1 for the first quartile or the 25th percentile. Now this might come out to be a little bit something different than what we calculated by hand. Some software packages will calculate the quartile a little bit differently than other ones. And so, or if we were to do it by hand. Overall, this isn't really that big of a deal because it's still just a measurement of around that 25th percentile. Now, the median should be the same, so quartile, again, we can type that out. This time I'm going to take the array and I'm actually going to lock it in place. So the way that we can lock this is press F4 and it'll put these little dollar signs around it. what that will do is then it will prevent that data from moving, and then I can start to drag my function, which will be a little bit easier for the last couple of measurements. So here my median is exactly the same. I'm going to drag this function down, and what I'll notice is it's still just the median, but now I can go in and I can change this to the third quartile, and then I can change this one to the fourth quartile, which is the maximum. So we can see that all of the main points, min, the median, and the max are the same. The quartiles are slightly different for each one of these observations. And so how does that then influence the interquartile range? Is it that big of a difference between the two? So let's go ahead and take a look. And it looks like this interquartile range, the middle 50% of the data using the software, will be around 75 versus 85 million. Now, this is a pretty big difference. So it depends on which software package you're using on what you will get for the first quartile or the third quartile. It doesn't really matter that these are a little bit different, just as long as you're consistent in what you're using. All right, so in this class, I will show you to use either one, and both answers are correct.